Number 2, we're going to be given a right triangle. We'll call this one RST. It's definitely a right triangle. And for this one, I'm just going to be giving you 2 sides, 2 side lengths, okay? This one up here, side SR, is going to be 5 inches. And the hypotenuse over here, TR, is going to be 5.7 inches. All right, so you're given 2 side lengths, and we need to get 3, right? We need to get that 3rd side. So can we use any of those 4 items, the Pythagorean theorem, the altitude, the special triangles, or trigonometry to get that 3rd side? Which one of those do we use? The Pythagorean theorem, right? When you know 2 sides, you can get the 3rd side. So this 3rd side, the side ST, is the side we want to find. So what should I put over here? X. So the first thing we're going to use is the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared equals c squared. Which side has to go in for c? The hypotenuse, okay? So we're going to say x squared plus 5 squared equals 5.7 squared. So the 5 squared you can do in your head, but the 5.7 you're probably going to need a calculator, right? So x squared plus 25, and then the 5.7 squared, you can use your little square button on your calculator, right? So you're going to go 5.7, and your calculator has a square button. If you press that, it's going to square it for you. Or you can type 5.7 times 5.7. And we've got 32.49. Did you get it before me? You're fast. All right. Now we just want to subtract 25 from both sides. That leaves us with x squared. You just want to take that answer, because it's already in there, subtract the 25. It's going to give you 7.49. And then to get x by itself, we're going to take the square root of both sides. And your calculator will do that for you too. So you hit second square root button. Then if you hit second, and then if you see this little ANS down here in blue, it's going to take that previous answer and plug it in, so you don't even need to retype it. It pulls it up for you, and when you hit the equals, it's going to tell you that that 3rd side is approximately equal to, and we'll round it to the nearest hundredth, so we've got 2.73, but next to it is a 6, so we're going to round up to 2.74. And that's going to give us the length of that 3rd side in inches. So this side over here is 2.74 inches. Now we have all 3 sides. Check, right? 3 sides. Then we look, now let's go inside that triangle and get all 3 angles. Do we know any of them? Just this one right here, right? What does the little box mean? 90. We know this one's 90, which means R and T have to be less than 90. And we just learned inverse trig, right? So you can pick either angle R or angle T. It doesn't matter. I'm going to pick angle R. And I'm going to use inverse trig, because I can use inverse trig to find an angle measure. Okay, so from angle R, I'm going to circle it just because that helps me. I can use the 2 sides that were given to me. This 5 inches will be the adjacent side, And this 5.7 is the hypotenuse. So which of the three trigs uses adjacent and hypotenuse? Cosine. So the cosine of angle R is going to be equal to the adjacent over the hypotenuse, which means if I do the inverse trig of those numbers, the 5 over the 5.7, it's going to give me an angle measure. And this is how you type it in your calculator. Second cosine, so make sure it has that little -1 in there, and then just type this fraction. 5 divided by 5.7, and it looks exactly like you have it on your paper, right? Hit the equal sign. And on my calculator screen, it says 28. So it's either going to stay there or round up. This one's going to round up to 29. Make sure you get that same number on your calculator that I got. So if angle R is 29 degrees, how do I get angle T? I know the triangle sum theorem. What does triangle sum theorem say? To 180, right? We start with the 180. We know the 90. We just found the 29. What's left? 61. Okay, now if I write the 61 in there, I have all three angles. Check. Okay, got all three sides, all three angles. This triangle is considered solved, right? We've got all the information we can get about that triangle. So that was when you're given two sides. Let's try it now when you're only given one side and one angle. So that's going to be example 3. See it? My hand's in the way. Let me move it up a tad. All right, so this time we're only going to be given one side, one angle. So the angle I'm going to give you is angle A. It's going to be 75 degrees. And the one side I'm going to give you is the hypotenuse over here. And that's going to be the square root of 6 centimeters. Luckily, it's a right triangle, so we already know one other piece of information, that this angle right here is what? 90. So should we start with sides or angles? Let's start with angles, right? Because we can get that one pretty quick. So angle B, you're just going to start with 180, subtract the 90, subtract the 75. What does that leave us with? 15. So angle B in there is going to be 15 degrees. And we've already got all three angles. Check. More than halfway there, right? All right. So now we need to get the other two sides. Either this side or this side. Doesn't really matter which one we go with first. So I'm going to start with this one right here, side BC, okay? And I'm going to use the angle that they gave us. Doesn't matter at this point which one you use, but I'm going to start with angle A. So from angle A, I've got an X in the opposite, and I've got rad 6 on the hypotenuse. So which of the three trig functions uses opposite and hypotenuse? The sine. Okay? The sine of that angle is 75 degrees. The opposite is x, and the hypotenuse is square root of 6. Should I use regular trig or inverse trig? Well, remember back to the beginning. Which one is going to help me solve for sides?
Regular trig?
Regular trig. So I'm just going to use regular trig here. So I'm not going to write the inverse this time. I'm just going to say regular trig, sine of 75. And right now, the x is being divided by the square root of 6. So I'm going to multiply by the square root of 6 on both sides. These guys cancel. So x is going to be equal to the square root of 6 times the sine of 75, which looks super complicated, right? Too bad I don't have a calculator. Oh, wait, I do. Okay? Calculator is going to do this whole thing for you. Don't try and do this in your head because you can't. So you're going to go second square root of 6. Make sure you close that parentheses off and then multiply by the sine of 75. Hit the equal sign, and it's going to give you this big long decimal, round to the nearest hundredth. So we've got 2.36. Next to it is a 6, so we're going to round up. And that's going to be approximately equal to 2.37. And this one is in centimeters. So that's this side, approximately 2.37 centimeters. We know 2 of the 3 sides, so at this point we could use the Pythagorean Theorem to get that third side. But I thought it was pretty easy typing in that calculator, right? So let's use trig again. So this time I'm going to use angle A again, but this time I want the adjacent side. And I'm going to call it y because I called this one x. So which trig function uses adjacent and hypotenuse? Cosine. Cosine uses adjacent and hypotenuse of 75 degrees is equal to the adjacent, which is y, over the hypotenuse, which is the square root of 6. And it looks almost the same as over here. I'm just using cosine instead of sine, right? So I'm going to multiply both sides by the square root of 6. So that they cancel out over here. And I get y equals the square root of 6 times the cosine of 75. And let me show you quick how to type in the calculator, but it's the same. Second square root of 6. Close that parentheses, multiply it by cosine of 75. Get this crazy decimal again. So after the decimal, I have 0.63, and next to it is another 3, so it's going to stay. So y is approximately 0.63 in centimeters. That's going to be this third side over here. So now we have all 3 sides. Check. We're done. Right? So we've got all 3 angles.